Well, that's my take anyway. We don't have to agree. We can agree to disagree on this.
But we do have to agree.
So we compromise on the tier then.
Yeah, we do have to agree on where we're going to put it. Hi everyone, I am Tony Blake and this is...
I'm Maria Vardakou.
Okay, and we're going to continue with our amino acid tier list. We're not going to go into detail of what we're doing. If you want more about that, then you can click on the link and see part 1. But we're going to jump straight in with part 2 here, starting with...
Methionine.
Okay.
Yeah, methionine is
this one's going to be controversial.
Controversial, yeah.
Okay, so this is methionine. Just to remind everybody what we're looking at here. This is an alpha carbon. Here we've got the acid group. This is the amine group of the amino acid. And for methionine, we've got this hydrophobic chain with a sulfur in it and CH3 on the end. So what do you think of methionine, Maria?
So I think methionine is quite special. First of all, it has a sulfur. I'm not sure of the role of that sulfur, but that makes it quite special as well, which is the yellow blob. Yep. But also, it's always the first codon, not the first codon, the first that is coded, or mostly when a protein is made.
Yeah,
so that on its own right, to my eyes, it makes it quite special.
I've got a slightly opposite feeling about that. I feel kind of, yes, it is the first protein added because it's the codon AUG, which is the start codon. But I don't know if that's just coincidence or not. If it's just that methionine is that unimportant that it only has one codon. And because it's the only amino acid with just one codon, then that codon has to do a special job. And that special job is starting translation.
Yeah, but if translation doesn't start, you don't have any proteins.
You don't, but that translation step could be any amino acid there, and it wouldn't matter to just starting translation.
But it's not any, it's methionine.
It is methionine, it is.
So I think we could go round and round in this argument. We had this argument before with Tony,
keep
actually.
Having the argument.
No, because it's going to be very boring for whoever is watching.
But I think as well, because a lot of proteins have the N-terminal part cut off, because it's often a signal sequence.
Yeah.
So in the actual protein itself, in the end, methionine isn't even there in the number 1 position.
Yeah, so you could argue that methionine is not important as a functional amino acid within the protein, but on its own right is a very important amino acid. Well, that's my take anyway. We don't have to agree. We can agree to disagree on this.
But we do have to
agree. So we compromise on the tier then.
Yeah, we do have to agree on where we're going to put it. So I think you would have it right up in S because you
I
think
would
it's
have it right
important.
up in S because it has it's not necessarily important. I think it's the way we say it. It's not necessarily important, but it's definitely unique.
It is. It is unique.
In that's why I would say that is special. So you'll go with my suggestion.
I'm not going to go with your suggestion. I just don't think it's as important.
Okay.
Please let us know in the chat and stuff, or in the comments below if I'm completely missing something. But I'll leave it high because yes, it is unique, and it is the only one that does that. I can live with that. So, but I'm not putting it in a special.
Okay, put it in the A's then.
It's in the A's.
All right.
Okay, moving on. What we got next?
Asparagine.
Asparagine. Okay, so again, this one looks a bit more complicated because it's got 2 amine groups, which makes it look difficult to spot where things are. But this is the normal amino acid part. This is the side chain. And the R group here is this. It's not a primary amine. It's an amide.
I think so.
Yeah. So what do you think?
It doesn't do anything for me, asparagine, actually.
Me neither.
Maybe because I haven't worked personally with any proteins where asparagine featured as something important. So I think it's important to remember that even in this, which is science, we all have our own biases, so we tend to be sort of influenced by the proteins that we have worked with. So just because I haven't come across
we're going to have our favorites.
Asparagine, it just doesn't. It's I could take it or leave it. So
it seems it looks kind of like a derivative of aspartic acid because it's the equivalent of aspartic acid, but it's not an acid, so it hasn't got that functionality to it. It's not a particularly reactive.
Not a basic functionality either, like lysine.
Yeah, it doesn't act like a base.
I would put it right down there in the D's.
But
We have to be mean with one of
We
them.
do have to be mean with one, but it's also, though, it does have the, if you're doing glycosylation, then the end-linked glycosylation is quite often via the side chain of asparagine.
Okay.
So, and a lot of proteins are not proteins I've worked with, and not proteins I think you've worked with either, but in nature, a lot of proteins that are
glycosylation is a
extracellular.
super important role, actually.
It's a role I don't know much about,
Yeah.
and I'm not an expert on.
No, it's an important role for recognition as well, and for signaling.
Yeah.
So, yes.
So I think that probably moves it up more than we generally would do otherwise.
Okay, then. That's fine.
Do you know where it comes from? Where it was
Asparagus?
discovered? Yes.
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 And I like asparagus, so... Okay.
Do you? I
so
don't.
for this, have you tried an omelette? It's really nice.
I don't want to talk in the video about why I don't like it.
Do you know, actually, apparently there are people that can smell asparagus?
Smell it?
Yes, so that baby had an asparagus milkshake, it seemed, of sorts.
That doesn't sound nice. I wouldn't want asparagus in a milkshake.
Interesting, though.
Though it's not asparagine that makes the smell. It's some other volatile compound.
Yes, a volatile
so,
compound.
Yeah, that was definitely a side story.
Sorry, you don't have to cut it. Yeah, you can cut it.
Right. So where we're going to stick it? Do we think that the whole end-linked glycosylation is...
I think it's important actually. Glycosylation is important. Not to an A.
There are other
Just
types of
because we don't like,
glycosylation.
we can be a bit biased. It's our
Yeah, we
tier,
can.
so
Down to B.
let's put it to
There's
B.
other types of glycosylation as well. It's not the only type of glycosylation. So.
Yeah.
Right. Okay, so that's asparagine. Also, it's an N, which is just confusing. It hasn't got a good one-letter code.
Yeah, but it has the in at the end, so for me it's quite easy to.
Asparagine. Yeah.
Yeah.
Okay, next we've got proline. Okay, proline's interesting, I think.
You see, that's another one that doesn't do much for me, although I do like its unique structure.
Yeah, so this is proline. Proline's quite different to some of the ones that we've looked at so far, because it does have a ring, but it's not aromatic. And because it has a ring, this is the side chain here. The side chain goes around in a circle and joins back on to this amide. So it's not actually listed as an amino acid, it's an amino acid, because it's a slightly different structure. So yeah, it's a strange one. But so you don't have that much interesting...
No, I do like its unique shape.
Yeah.
I do like that it's the nitrogen. So it's one of these that is, you can't mistake it for anything else.
Yeah.
So when you're asked to recognize amino acids, not necessarily draw them, but from a list, if you see amino acids without names, proline is one of those that you could definitely be 100% certain that that's proline. So that by itself makes it quite likable.
Yeah.
the not confusion factor. But I haven't, again, it's one of those that I haven't really played around a lot with, so I don't have a...
I haven't, but I think it does have important things. So it's one of the few amino acids where rather than having a trans peptide bond, you get a cis peptide bond, which means it can have a real kind of like tight kink in the backbone. And that tight kink allows it to make structures that other amino acids just can't do.
Yeah, I think it's quite unique, so I would put it up there just because of its
so I think things
uniqueness.
like beta turns, it's really key for beta turn. It's hydroxylated in collagen, which you know is important for that specific collagen helix. So I think it is important, not a favourite probably.
No, but maybe a B, at least a B, right?
I think at least a B.
Yeah.
Not an A. I'm kind of tempted by its giving extra structures.
And actually, you know what? We I think we want to put things in other places rather than A's, but this, I think also, this exercise shows how when you really look into it, all amino acids, or most amino acids, actually have some
a real
important function.
Like a specific characteristic that makes them important. And that's why we're thinking, well, it's important. This one's important and this one's important. Yeah. Okay, what we got next? Glutamine?
Yes, it's glutamine is the next one.
So, let's get the horrible thing out of the way. It's a Q. It's a one-letter code.
Yeah, I always struggle to remember that actually as a student.
Yeah. So here, this one, it's very similar to asparagine. So there's the amino acid part. Here's the R group. It's just got an extra CH2 in it, so it's slightly longer. It's got that amide on the end.
Mm-hmm.
I don't really have any strong feelings about it.
No.
Yeah, I think it's physiologically important. It's like it's
Because
found in high
basic,
concentrations.
Yeah.
I don't know that much about other things it does.
No.
It just seems very similar to like asparagine, but doesn't do, as far as I know. You don't get kind of glutamine linked things, as far as I know.
No. No,
So-
yeah.
Let's not spend a lot of time on it.
No, let's move
Are
on.
we putting it low? Down
Put
at
it
a
low,
C?
yeah.
A D?
Yeah.
Is it our first
Let's
D?
have one in the D's, come on.
Yeah, like that's again. This is just because me and Maria have no affinity with it, and we don't really
Yeah.
use it. Never used it. Never come across it much. So there we go. Okay, and then next we got arginine. Yeah, so arginine. It's a quite a long chain there with this like nitrogen heavy.
Very
Group at
heavy
the end.
nitrogen,
It's
yeah.
a guanidino group.
Hmm.
I have something against the guanidino group in that I
What?
cannot draw the thing.
Ah,
You know, if there's one amino acid that I always get wrong when I'm drawing it, it's
it's
this one.
arginine.
Yeah, because it's
Yeah.
got a strange combination of
It
single
is
and double
quite
bonds
strange,
there.
yeah. Quite
Um,
unique though again.
It
though.
is definitely unique. It can act as a base, but it's not as reactive as lysine.
Yeah.
Long chain, it allows you to tell the pirate joke.
Yes, it's true. And also it makes you remember the R, which is quite
Mhm.
nice. I don't know, maybe a C or a B.
Yeah, it's a
C.
good replacement for lysine if you're kind of making.
Yeah.
You want to not really change the properties of it that much, but you want to take away the reactiveness of the
Of lysine,
primary,
yeah, you would,
primary
yeah.
amine.
So
put
if
this
you don't
one.
want to change the structure too
Yeah.
much, yeah. It has a nice
Just
nice
stable.
practical function for us when,
Yeah.
when you engineer proteins, but
But other than that, I'm not really
no,
super excited
let's
about
put
it.
it in the C's, I think.
I think so as
put it in
well.
the C's.
Yeah. There we
So a few more to go, right?
Yeah, there's
so
another 5 to go.
we have serine.
Yeah,
Next.
serine next. So serine
Well,
looks boring, but
It looks boring, but
But I
it's
think we
actually
both
very
kind of-
important, I think.
I think yeah. So this model's slightly different. It's just the one I could find. It's got the kind of, isn't it? It's a small amino acid. Very small. So this part here is the acid. It's the base.
It has a hydroxyl there, though,
Yeah.
which makes it really reactive.
And then it's got this hydroxyl. So it's
Yeah.
got this alcohol group on the end.
Exactly.
So it's involved with a few things, but I think the thing that we mostly care about are the serine proteases.
Exactly.
Right.
And they're very important in blood
Yeah.
coagulation.
Yeah.
So we can all relate to that, I think, whenever we cut ourselves, we have an injury or
Yeah.
whatever, our surgery, or we are heavily relying on blood
Yeah.
coagulation, and this is a series of serine proteases
Yeah.
that control that pathway. So I would have it right up there, actually.
Really?
If not in the S's, at least in the A's.
I think maybe in the A's. I think it is like you said. It's such a good classic example of an active site that is obviously we teach it and we talk about it a lot. It's very well characterized.
Having said that, it doesn't work so well on its own, though. It needs to have its buddies there.
yeah, for it to work in the
Histidine and
active site.
aspartic
Yeah,
acid.
it does.
So it has them. It carries the name,
Mhm.
but it doesn't do it on its own.
It's also though it's the smallest hydrophilic amino acid.
Mm-hmm.
So if like when we talked about alanine, when we said about if you're going to make a mutation, make it to alanine. If you're in an area on the outside of the protein and you want to make sure that you keep it hydrophilic, then
You put
serine's a
the
good
serine.
choice for that.
Yeah.
So it's kind of useful for that.
Mm-hmm.
So I think it's up there. It's an A or a B, I would say.
Okay, I'm happy with A or B. I mean, personal would be an A, just
Let's
because,
stick
though,
it in
again,
A.
I have this
We've got an affinity with
affinity
it.
with it.
Yeah,
now.
we both teach about serine proteases, so
Yeah.
we've talked about it a lot. So yeah, it's going up there.
Okay, then we have threonine.
Yeah, threonine. Threonine's probably a good one to follow after serine as well.
Yeah, it also has this hydroxyl, doesn't it? But
Yeah.
it's slightly longer,
And it's threonine. It's kind of as well as being longer, it's just more bulky
more bulky. Yeah.
because so it's not a primary alcohol in serine. So it's not it comes off here where you've got the CH3 group that follows it, so it's just slightly more complicated. Again, one that I get wrong quite often if I'm drawing it because of that.
I don't know. I don't have a strong opinion about threonine again. It's not one I have worked a lot, but
there are post-translational modifications happen to it, but it's not one of the key. It's not one of the, it's not one of the more important ones there.
I would say B or C for threonine.
Yeah. It's a lesser serine to me. Yeah, so threonine. Let's stick it down in C.
Okay.
Yeah.
And then we have
Valines.
valine.
Right, so this
Quite
is
bulky
valine.
valine, no?
Very bulky, yeah. So it's the kind of medium. It's not as long as your leucine and your isoleucine, but it's bigger than alanine. It's your kind of bulky. It's
quite
V-shaped here.
hydrophobic,
Yeah,
bulky.
and that's what it is basically. It's
Yeah, it serves a very
it's structural. It's just kind
structural.
of it's just there
it has
as
a
your
structural
hydrophobic
purpose, but
filling structure.
it's not very reaction sort of important.
I think kind of earlier on when we said we didn't think much of leucine and isoleucine, but we kind of pushed them up to a C. I kind of feel like this one's not even there. This one's just
I would put it in a D.
dull to me. Yeah, I think it's going in a D.
Yeah.
I think this is possibly my least favourite.
And it's difficult to draw, so another minus.
I don't think it's that bad actually, because it's
quite
a straightforward kind of.
Yeah, it is straightforward,
Yeah.
but it's quite large, bulky.
Okay, so that one's all the way down there.
And then we have two more.
Next we have tryptophan.
Well, tryptophan has to be up there, Tony.
It does, doesn't it?
Yeah, two rings.
Well,
I mean,
it's my favourite.
It's beautiful, yeah. I like
exactly.
tryptophan.
It's beautiful because it's got this big, bulky looking thing here. It's also...
It makes our life very easy as well in the lab, doesn't it?
Yeah, because it's fluorescent, so it's like a built-in probe of protein structure.
I love tryptophan because of that. It makes our life so much easier when you want to follow any protein purification or just in the lab, when you do any sort of experiment with proteins, you stick it under the sort of in a spec, the 280.
Yeah, it absorbs at 280 really strongly, so you can see. As well, it's rare that you get more than one tryptophan in a protein, unless it's really big, or unless it's doing something really specific. So you often just know, well, you've got a tryptophan in that protein, so you can use that specifically as a probe. It has different fluorescence when it's exposed to solvent compared to when it's buried.
Yeah,
so you can see whether a protein's folded or not by its fluorescence.
It gives you information about the folding, exactly.
Yeah, so it's great for that. It looks complicated as well, but it's not that hard to draw.
Yeah.
If you do some little tricks, I'll show you little tricks. It's a house with a blue chimney, and
is it?
Yeah, because it's a 5-membered ring.
Okay.
So it's a house with a blue chimney and
with
strong
an
walls.
Annex, with a big garage.
With a big garage or a big annex or a conservatory, a hexagonal conservatory.
I've never seen a house that has a bigger garage than the house. But okay.
But if you think of that when you draw it, then it's not that difficult to draw.
Pool house.
But it's still the pool house.
Okay, that's all right.
But if you can draw tryptophan, then you're like, oh yeah, I can draw that amino acid, and it looks like you know your stuff.
Yeah.
So we're putting that near the top. Well, at the top, because it's the best. I'm going to put it right over here because to me, it's my favourite.
And tyrosine is tryptophan's
Tryptophan
slightly
light.
poorer cousin.
Yeah. And then the last one that we're going to talk about is...
I feel quite sad for tyrosine actually, because it's always shadowed or overshadowed by tryptophan, isn't it? Although it is quite important as well.
Kind of on its own, you'd be like, oh, tyrosine's a great amino acid.
Yeah.
Look at this beautiful ring system and everything.
And
I go like,
you see tryptophan and say, okay. So I mean, it does fluoresce a bit as well, but we don't rely on that
It's
so
got good
much.
absorbance.
Yeah.
And it's more common than tryptophan is. So often proteins will absorb at 280 because of tyrosine, even if they don't have a tryptophan.
Even if they don't have a tryptophan,
Also, though, tyrosine kinases, like signaling molecules, are very, very important.
Yeah.
Like so many signaling molecules are kinases, or kinases that kinase other kinases, and then you get the whole signaling cascades and things. And because of that, I think it's important.
It is important, yeah. I would put tyrosine in the A's. I
think it's definitely in A's. It's not quite up there because it's not as good as tryptophan, but it's still good. So it's gone up there. So we're done.
And I think we're done, yeah.
So anything
I'm quite happy with that.
Before we move it, you're happy with it? Anything you want to move?
No, I think
Yeah.
I'm quite happy with that actually.
Yeah. So this is our tier for amino acids, for the 20 amino acids that you find in proteins. We're not saying this is definitive. We're not saying this is the best. This is our opinion. If your opinions differ, feel free to write something in the comments below. So I'll thank Maria for helping with this. And
Thanks for inviting me.
we'll say goodbye.
Goodbye.
Bye.